Hello everyone. We're now going to try to compute the Pareto-efficient curve, having spoken about the condition that the marginal rate of substitution of the one player must equal the marginal rate of substitution of the other player in order for us to find it. So, here we're going to assume that Ayanda and Biko have identical preferences. Now, when that occurs, we get the following Edgeworth box. And so in this Edgeworth box, we can see that we're going to have a linear Pareto-efficient curve. The Pareto-efficient curve goes from the origin from Ayanda to the origin for Biko. It's just going from one corner to the other. So what that means, it's just going to have to be an equation for a straight line. So that's what we're going to have to find here. So we can see that the Pareto-efficient curve is going to be linear, and so we have to think, how do we find this thing? How do we find this equation? So let's start with their preferences. We have the utility function for A and the utility function for B, and both of them are Cobb-Douglas with alpha equal to 0.5. And remember that x bar equals x to the superscript A plus x to the superscript B. So that's the total amount of x in the economy must equal the total amounts given to Ayanda and Biko. And similarly for y, we've got ya plus yb equals y bar. Now remember, in our economy, there are 10 units of x and there are 15 units of y. Okay, now another thing to remember is that if this is Ayanda's utility function and this other one is Biko's utility function, what does that mean? It means that their marginal rates of substitution, Ayanda's marginal rate of substitution, equal to her marginal utility of x over her marginal utility of y, that is going to equal the ratio of the goods ya over xa. Now this is true because they have this identical Cobb-Douglas preference. So Ayanda has these preferences, and so you might remember there would in fact be a 0.5 over here and a 0.5 over here, but those 0.5s cancel, and so we're just left with ya over xa. Similarly for Biko, we'd have MRSB equal to the marginal utility of xb for Biko and the marginal utility of yb for Biko. That's going to be equal to the ratio of his amount of yb, over his amount of xb. Now, here's where the trick is going to come in that we're going to work with. xb and yb and xa and ya. How do they relate to each other? Well, let's look down here. We've got xa plus xb equals x bar. Ya plus yb equals y bar. Okay, so what does that mean? It means that we have conditions to substitute in for xb and yb. We can put numbers in for xb and yb that are in fact to do with xa and ya. Okay, so how do we relate those two? We can rearrange these equations. xb equals 10 minus xa. yb equals 15 minus ya. That's just a simple rearrangement of the condition that the sum of the two goods must equal the total amount of goods available. What this means then is that B's marginal rate of substitution equals 15 minus ya divided by 10 minus xa. That is equal to B's marginal rate of substitution. Okay, so I'm telling you this now because we're going to have to now find an equation where we set the marginal rate of substitution for A equal to the marginal rate of substitution for B. Remember, along the Pareto-efficient curve, what do we require? We require that A's marginal rate of substitution equal B's marginal rate of substitution. Okay, so let's do that on the next slide. So we need MRSA equal MRSB. Now what was that for A? For A it was YA over XA. What was it for B? It was, with our substitution, 15 minus YA all over 10 minus XA. Okay, excellent. Now, here's the thing. What can we do? We can cross multiply. we can cross multiply. When we cross multiply, we're going to take 10 minus xa and multiply it over here. We're going to take xa and multiply it over here. So let's do exactly that. We've got ya multiplied by 10 minus xa. We've got that equal to xa multiplied by 15 minus ya. Okay, now let's multiply those out. What are we going to see? We're going to have 10 multiplied by ya minus ya xa. That's going to be equal to 15 xa minus ya xa. Okay, so what can we see here? Well, we can see that we've got 15xa and 10ya, and then we've got minus ya xa on both sides. What can we do with a minus ya xa? That just cancels out. Now what do we have? We basically have the fundamentals for an equation. We've got 10ya equals 15xa. We want to function y as a function of x, right? So we've got y equals a function of x. We need y is a function of x. And so what do we want here? We want to divide through by 10. What is that going to leave us with? Ya is going to be equal to 15 over 10 xa. How else can we simplify that? That is equal to 3 over 2 xa. And that is our equation for our Pareto-efficient curve. That is our PEC. That's equation for the Pareto-efficient curve. And what can we see? That is a linear equation. It's going from the origin 0, 0 for A all the way up to the corner for yb equals 0 and xb equals 0 up in that corner. And we could draw this because we could substitute in the values for xb and yb. For xb, it was 10 minus xa. For yb, it was 15 minus ya. And we could substitute those into b's Pareto-efficient equation, b's marginal rate of substitution in order to get the equation for the Pareto-efficient curve.